All right, in this part of the series, I am not going to be using the web console shell. I'm going to be using the Windows subsystem for Linux. I'm using version 2, which came out recently. If you haven't used the WSL in a long time, they had Legacy version 1 and version 2. Version 2 is sick. You got to upgrade and check it out. Anyways, so yeah, once you got it installed, just do bash, and now you're in bash, so you're good to go. What we need to do is we need to SSH into the Pico server and type in my top secret password, and we're in. Cool. All right, so this is the cryptographic thing I skipped last time. Basically, they give you a table and it looks like this. It's much easier when you put it in an Excel like this. And the key is right here, solve crypto, and then the hash is right here. So what you do is you click the S and then you look for the U. So we found the U, and then we go up and we find the C. So the first one is C. All right, so now we find O, and then we go across and we look for F. When we find F, we go up and we get R. Once you solve that out, it spells crypto is fun, I believe. So let's try that out. And that worked. Gorgeous. Okay. The vault uses some complicated arrays. I hope you can make sense of it. Special agent. The source code is here. So let's grab that. And basically what it's doing, it just has a fancy way of indexing through the password and doing the comparison. So all this is, it's just jumbled up. So I'm just going to grab this. I'm going to delete everything. I'm going to paste it in. I'm going to format it a little, remove this. And then what I'm going to do is I'm going to sort the line lexicographically. And it's almost in the right order, but it's not. So let's go down here, grab these, put this after 9, and then we have the 20s. We'll go after 19, 30s down here. So now we have it written correctly. So once you've unscrambled it, you get the flag. It's quite easy, and paste that in, and it worked. Great. All right, what's a NetCat? So we need to use NetCat to connect to this thing at port 4185. This is just like teach you how to use NetCat, right? So NetCat, and then you just put in the port right after it, and we're NetCat masters. Cool. Easy. Can you find the robots? All right, let's open up this site. Where are the robots? Basically, every website, you will have a file called robots.txt, and that tells web crawlers like the Google bot, the Bing bot, the Yahoo bot, etc., on what they can spider and what they can list in their index. It's a mistake to put in sensitive URLs in here, because all you gotta do is look at robots and you're gonna find all the sensitive information right there. And so you don't want to do that, but it's a little technique that can show you about maybe how their website's laid out and maybe where hidden areas are. So we'll use it to get the flag. Easy enough. You beat the first overflow challenge. Now overflow the buffer and change the return address to the flag function in the program. Great. So let's go to this folder. See what's in here. Let's cat vuln.c and see what the source code is. It's kind of like what we looked at the last overflow. We create a buffer of a defined size, 64 bytes, and down here we call vuln, which calls this, and then we get our shellcode and we put it into the buffer, and then we're going to print f. Whoa, we're jumping to this address, and the address we're jumping to is going to be the return address. So basically, when this function starts executing, the return address is going to be right here, right? So it would just return execution. So what we can do is let's just run vuln and give me a string, and let's see what happens. And we'll just type some A's. And whoa, we're jumping to 0x80487005. So I'm assuming that address is basically 1 byte or 1 instruction after vuln, right? Type of thing. But what happens when this vuln executes, it gets our shellcode, it puts it into buffer, And then the next thing it executes is it executes the get return address, obviously before we call printf because it needs that address. So the idea here is we want to call a flag. We want to change the return address by overflowing this buffer. So that's the goal. So the first thing I'm thinking here is it's 64-byte buffer. So we want to, well, let's put in 64 A's and see if that return address changes. The return address is the same, so we can run again. Let's just put a lot more A's in. We just want to see if we can overflow that buffer. So 0x61, that's an A character, right, in hex. And so why does this overwrite the return address? So this get return address here just puts it's just a stack variable, right? And then our buffer is also on the stack. So we're just overflowing the stack buffer to overflow into this variable. Now you might think 64 chars is the size of the buffer, and so if we did 65, that the first A would end up in get return address, but that's not the case. So it's kind of like a trial and error thing. So to get the exact address, there's a few things you can do. Is GDB on here? No. So let's go over to this and let's wget this. We're just going to show you how to do this on the local machine here. So we downloaded vuln and we want to use GDB vuln. So this is going to use the GDB. What? Do I really have to do this? I guess I do. We're just installing that package from the apps package manager. And now we will GDB vuln. And this is the GNU debugger. There's going to be symbol names in this binary. And so we can set breakpoints by doing B. So the function we want to breakpoint is called vuln. So we can do B vuln. And it will tell us the breakpoint is at this address, 0x80486663. If we do B flag, it'll give us the address of the flag function. So when we saw up here, the return address is 8048705, and that is probably the address of where vuln is called, or right after it, right? And so this can give you an idea of how many bytes you need to index into and what you want to overwrite. But for me, I just find it much easier, of course, to use IDA. So what we will do is we're going to wget vuln. We already did that, and now we are going to look at that in IDA Pro. So now we are in IDA here. We can look at the vuln, and it'll give us the address of vuln, which is 804.865F, and we want to call flag, so we want to change the return address to this address. So flag is 80485E6. So we're going to overwrite the buffer, and we want that address to be the last 4 bytes. That's the last thing that we want to happen. Sorry, I'm retarded right now. We are going to overflow the buffer with a bunch of A's, and then at the address where the return variable is, the return address, we are going to put the address of flag there. So now back to the vulnerable program. Basically, I started at 64 bytes, 64 A's, and I just kept increasing that number until I got to overwrite the correct return address. So this is 75 A's. If I put 75 A's in, nothing happens. Now let's put 76 A's. And now we see that first byte there is overwritten with a 0, and that's the null terminator. Let's do it again, and we'll do 77. And now we get the null terminator in our first 61, which represents an A. So I kept doing that until we got to 80. 80 A's is all of them with A's. So now we know that we're going to do 80 A's, we're going to remove the last 4 A's, and we're going to put the return address of the flag function. I'm going to paste in our shellcode just like we did last time. There's 76 A's, and then the last 4 bytes are going to be the bytes which represent our return address that we want, the flag function in a little endian, right? And so now we hit enter. Okay, so that worked. It jumped to the flag function and then executed it, which then just prints our flag. So there it is, we got it. This is the So Meta challenge. Find the flag in the picture. It is just a regular old picture. Could have a secret code in there, but I think it's just going to be in the binary somewhere. You can also find that in this folder. So let's go there and let's take a look at the hint. What does meta mean in the context of files? So we want to look at the metadata of this file. So let's cd over there, see what's in there. So there's a couple of ways to get more information on a file. We can do ls-l, and that will show us the permissions, the usernames of the owner, I believe, the date it was modified, and the file of the picture. But that's not enough. We can do a file, and that will give us some additional information. But the real information we want, I think, is stat. When we run that, even more information, but again, there's no flag there. So let's see what else we can do. We can do strings, Pico, and then grep it with picoCTF. And there's a flag. Okay, that was too easy. So metadata is going to be in the file, right? Just as a regular string. So this is probably another way to get that. But strings and grep can solve a lot of problems. So there we go. What lies within? There's something in the building. Can you retrieve the flag? So it's just a picture. I'm going to guess this is steganography. There's data encoded somewhere. There might be an online decoder. Yes, there indeed is. There are many. So what you can do is you can take your image and you can upload it to this steganography website, and it will decode it, and there's our hidden message. Easy, right? All right, extensions. This is a really weird text file. Can you find the flag? Yeah, probably. So let's copy that address. Let's wget that as well. And then we are going to just, let's cat flag.txt. And it says it's a PNG right up here, right? That's the magic bytes that represent the file identifier. So we just need to change it to a PNG. And we can do that with move, I believe is how you do this. Rename a file, move flag.txt, flag.png. And now we can go to the download. We can open our flag. And now you know about extensions. Okay. Really pushing the boundaries of my skill level right now, huh? Shark on the wire. We found this packet capture. Okay. So recover the flag. So I would probably do that. Packet capture. I would use Wireshark to do that. All right, for this challenge, so we have a pcat file, and we're going to drag and drop that onto Wireshark. It is going to open up our stream of packets here, and we need to find Pico, right? So what first thing I tried was packet logger info contains Pico, and hit enter, and nothing comes up. So it's not that simple. It must be encoded 1 byte at a time. So let's just look for Pico, and we get nothing. So let's go back to the hints here. It says try using a tool like Wireshark. Yeah, we did that. What are streams? So we just want to see streams. So let's find, how do we analyze? We want to filter by streams. Prepare a filter. Follow UDP stream. Okay, cool. That does not look helpful. All right, so there's some other filters we can use. I think we do IP proto. Let's look for UDP packets only. And we get nothing. What the hell? All right, let's look at TCP. Again, nothing. Do I know what I'm doing? I thought I did anyway. You don't do this to me. Okay, yes. It has to be capitalized. Syntax. What if we do TCP? TCP is not exciting, so if we look down here, we can see what the data is. I'm saying that what we're looking for is going to be UDP. And we want to find Pico in here somewhere. So if we scroll, just look down here and scroll through, and see if we see something that pops out at us as Pico. This is the same packet every time. All right, let's do right click and follow UDP stream. Nothing. Let's look at all these different streams. So let's look at UDP stream 1. Let's look at stream 2. I think we already looked at that one. Let's look at stream 3. 4. They're all the same packet. This is trash. 5. Oh, I see Pico. We've got Pico, dude. Oh, I think we got it. Okay, stream number 6. If you look here, I see a P, and then the second packet, an I, a third a C, an O, C, T, F. Okay, that's definitely our stream we want. So now we have the fun job of transposing that information. Lovely. All right, P-I-C-O, CTF, and then S, T-A-T, S-T-A-T. Okay, we got it. To get truly elite, you must understand different data encodings, such as hexadecimal. Oh god, I don't like this challenge. You're going to see why in a second. It's timed, I think. So for this part of the challenge, we are going to use these two websites which can quickly convert ASCII, hexadecimal, and octal, etc. So let's NetCat in and do this little time challenge. So we've got some binary. We need to turn it into a word. And it's Falcon. We want this as a word. This one's tricky because it's octal. I never would have dreamed of octal being in here, but it is. We need this as a word. I assume this is just hex. Test. Oh, okay, that was easy. All right, client side again. Can you break the super secure portal? Sure, we can. New and improved login. Verify. Let's view page source, and it looks like it's just this one JavaScript function right here, verify. So let's grab this, and then we'll get some syntax highlighting. We need to format this. To format this, we can actually just drop the Java right into the JavaScript beautifier here. We'll grab that, and then we'll paste that in. Now we can get a better idea of what we're looking at. This is more of this just substring crap. It's basically, it's parsing each section, each group of letters by the substring, and it indexes through the substring it's basically start with the 0 byte and then end at split times 2. We know split is 4, so we can just do a find and replace on split and replace it with that. This is basically a string. It's like an array of strings that makes up our full string. We can see picoCTF here. An opening bracket, an ending bracket. And yes, we could go through this and we could, like we did in the last challenge, was organize this like, okay, this row comes after this row based on the index of the substring, but they've made this too easy on us because we can just deduce what it is pretty easily. picoCTF, not this again. And I bet you that's it. And it works. Can you find the flag? We're going to be using grep again, so let's pop over there. ls. We have a bunch of files. So picoCTF is somewhere in those files. I think they just want us to do a recursive grep. So I believe we do that just by doing grep-r, and then we want to define the current folder with a dot, and then our string, which is going to be Pico. Oh, I did it wrong. Okay, grep-r Pico dot. Boom. And it found it, and there it is. Cool. So that's how you do a recursive grep. What do the flags mean? Okay, I had to Google this one. So these are nautical flags. So it's just a one flag to a one letter transposition of the characters, or translation, whatever you want to call it. So we're just gonna look that up real quick. All right, a quick Google search gave us this little chart which defines them for us. So let's just translate them over. And so the first thing we got is a P. Oh, we already know it's picoCTF, so we just need to go to the brackets. F. I'm actually having a problem here, so we know this is an F, but this flag doesn't appear on here anywhere. I have no idea what it is. I'm just gonna put a star in for now. F-A-G. I mean, it's got to be an L. It has to be an L. It can't be anything else. Flag. There's another character that's not correct either. This doesn't exist anywhere on the chart. I've looked at 3 charts, and they don't have these. Very bizarre. I'm going to have to skip that one, too. I hate this challenge right now. Oh, okay, so that's an underscore. The random flag that doesn't exist is an underscore. So flag and T U flags and tough. That doesn't make any sense. F-L-A-G space A-N-D space T-U-F-F. That can't be right. Alright, I've now consulted about 30 of these charts here, and this is so strange. The only thing this looks like is a 1. So that's not a L. Oh, it's fucking Leet Speak again. God damn it. F-L-A-G. Are you kidding me? That's a 5, not an S. It's Leet Speak. Flags and stuff. Oh my god, I hated that challenge. That was terrible. Alright, Mr. Worldwide, a musician left us a message. Okay. And there is the flag encoded in what looks like float variables. Oh, I know what this is. These are coordinates, I bet. Like longitude and latitude. So let's grab this first one and let's paste it into Google Maps. And we get someplace in Kyoto, Japan. So what I did here was for each one of these, I wrote in Kyoto, Japan. So we have the city name and the country. And then I went here and went to the next one. And we get Odessa, Ukraine. And basically, once I finished doing that with all of them, this was my output, okay? Kyoto, Japan, Odessa, Dayton, and if you look at the first character of the city, we get Kodiakalaska, Kodak, Alaska. So that's our flag. How is this wrong? This is just straight up rude at this point. Oh. Thank you. We got it. You needed a underscore in there.